For most of human history, the Milky Way was a quiet mystery that drifted overhead without ever offering an introduction. It never announced its size. It never hinted that it was a swirling structure made of unimaginable distances. It simply stretched across the night sky, a pale, soft ribbon, as though someone had brushed a thumb across the darkness and smudged it with light. People looked at it for thousands of years, perhaps while tending night fires or watching over sleeping animals, and believed it was exactly what it appeared to be, something gentle and close, like a faint trail of frost set against the dark. Nobody suspected that it was, in fact, the grand home of hundreds of billions of stars, politely declining to reveal its full scale. Before we drift through the quiet wonders of the Milky Way, take a gentle moment to like and subscribe to the Late Night Scientist channel, and let me know in the comments when and where you're listening, so this peaceful science can reach more sleepy listeners easing into rest. Imagine for a moment a traveler in an early world, long before telescopes, lying on cool stone or warm sand, letting the night settle around them. Above, the Milky Way would have appeared not as a galactic structure, but as a kind of celestial weather, an atmospheric feature that didn't quite behave like a cloud, yet didn't behave like anything else either. It was simply there, in the same dependable place, shifting slowly with the rotation of the Earth. It had a softness, the kind that feels both comforting and mildly confusing. Some nights it looked luminous, like spilled milk. Other nights, it was faint and almost shy. Its whiteness invited stories, because something that subtle almost demands interpretation. Many cultures created gentle tales to explain it, stories that tried to account for its position, its shape, its persistence. Some thought of it as the pathway of spirits, or as the dust left behind by wandering celestial animals. Others imagined it as a river of light, flowing across the sky in a way no river on Earth ever could. These interpretations had something in common. They all assumed the Milky Way was near, something just beyond the reach of tall mountains or the highest storm clouds. Nobody imagined it was anything like a galaxy, because the very idea of a galaxy did not exist yet. And even if it had, the Milky Way did not look like one. It looked like something delicate and local, as though it could be touched if someone only built a ladder tall enough. The galaxy, for its part, never offered any correction. It continued to shine in its quiet, sideways fashion, revealing individual stars around its edges, but hiding its true structure behind a veil of distance. If galaxies could have personalities, the Milky Way might be the sort that enjoys understatement, the kind that shows up to a cosmic gathering wearing muted colors and then casually reveals it contains more than 100 billion stars. It might be the type that survives for 13 billion years, simply by minding its own business and saying very little. The turning point came only when the telescope arrived, an invention that, at first, humans used to look at ships, mountains, or planets that felt comfortably close. But the moment anyone pointed one toward that pale band, the illusion dissolved. Instead of mist, the telescope revealed stars. Not dozens, not hundreds, but thousands packed so tightly together they resembled a single continuous glow when viewed with the naked eye. It must have been a shock, an almost comedic one, to realize that what people had been calling a cloud was, in fact, something so densely populated that no unaided human eye could distinguish its parts. Still, even then, the full truth remained hidden. People saw the stars, but didn't yet understand the structure. The galaxy continued to keep its secrets by virtue of our position inside it. It's remarkably difficult to deduce the shape of something when you're living in the middle of it. It's like trying to sketch the outline of a forest while standing under its tallest trees, or trying to guess the shape of a grand cathedral while sitting quietly in one of its pews. The Milky Way revealed its stars, but withheld the larger picture, as if to say, "You may look, but only from this angle." There's a gentle humor in this arrangement. Humanity spent thousands of years studying the night sky, charting bright stars and wandering planets, predicting eclipses and tracking seasons. We mapped the heavens with extraordinary care, yet the largest structure we could see, the one we were actually inside, remained unidentified. It was like trying to understand a book while forgetting to consider the page you're currently reading. Only with time, patience, and the help of increasingly clever instruments did we begin to sense the Milky Way's true nature. And even then, understanding came gradually, spreading slowly across generations of observers. People pieced together star positions, measured faint variations in brightness, and compared patterns from different latitudes. Bit by bit, they discovered that the galaxy was not a local cloud or a ribbon of sky dust, but an enormous system spinning quietly in the cosmic dark. Looking back, it almost feels like the galaxy enjoyed the misunderstanding. There is something endearing about a structure so vast and intricate managing to remain mistaken for a streak of atmospheric haze. For ages, it passed as something modest, even bashful, as though it didn't want to make a fuss. The universe contains objects that flare, explode, collide, and twist with dramatic flair. Meanwhile, the Milky Way simply drifted, luminous but unassuming, waiting for someone to notice the truth. And when we finally did, the revelation did not diminish its quiet beauty. If anything, knowing its scale adds a deeper calm. That pale smear of light above us is not a delicate mist, not a ghostly river, not the remnants of mythical creatures. It is the collective glow of countless distant suns, their light softened by distance until it looks like a single stroke across the night. It is vast beyond comprehension, yet gentle in appearance, a cosmic giant that hides inside the disguise of a modest cloud. In that soft disguise lies its charm, and perhaps its lesson. The grandest things do not always announce themselves. Sometimes they appear as something simple, familiar, almost overlooked. And sometimes, for thousands of years, that is exactly the right amount of mystery for a night sky to have. When you stand in the middle of a great city at night, something curious happens. You can see the streetlights, the windows, the glow rising from the pavement, yet the overall shape of the city, the elegant curves of its avenues, the full sweep of its skyline, remains invisible. You sense you are inside something vast and organized, but all you truly see are the nearest, brightest points of light. The rest is implied, suggested by shadows and distance. Living inside the Milky Way is much like that, except the city is 100,000 light-years across, and the streetlights are stars scattered so widely that many of them will never be close enough or bright enough for human eyes to notice at all. If this galaxy were an actual city, its scale would be outrageous. It would have an urban sprawl so large that crossing from one neighborhood to another would require longer than any species has existed. Even our cosmic block, the region immediately around the Sun, contains stars drifting in slow, stately orbits that seem almost indifferent to our presence. They pass by one another over millions of years, as if pausing to nod politely before continuing on their solitary paths. From our little sidewalk within this vast stellar metropolis, we see only a tiny collection of bright lights, the stars that happen to be close enough and luminous enough to pierce our night sky. They appear scattered, irregular, casually arranged, as though someone tossed a handful of glowing grains and let them fall wherever they pleased. But this impression is only a trick of perspective. In truth, the stars around us belong to a colossal, coordinated structure, with sweeping lanes and subtle patterns, the kind that only reveal themselves from far, far above. Standing inside the Milky Way and trying to understand its layout is like strolling down a narrow side street and attempting to deduce the design of an entire continent. The galaxy around us contains hundreds of billions of stars, each with its own story, its own orbit, and its own lifespan. Most of them exist without the slightest chance of ever being glimpsed from Earth. They burn quietly in the deep, well beyond the reach of unaided eyes, and they seem content with that. If the Milky Way were truly a city, these unseen stars would be the quiet apartments in distant towers, lit softly by residents who rarely open their curtains. Their light doesn't travel far enough or brightly enough to attract attention. Yet they contribute to the overall glow, an unnoticed majority shaping the character of the place without ever asking for credit. Every so often, we catch a glimpse of the galaxy's deeper population through telescopes, vast clusters where stars gather like neighborhoods built around a shared courtyard. Some stars are young and brilliant, shining with the bright confidence of youth, while others burn dimly, aged and steady, their light softened by time. They coexist without fuss, drifting in parallel, held loosely together by gravity's gentle insistence. The city is always in motion, though it moves so slowly that even the most patient observer might forget it is happening at all. From our vantage point, it's easy to think that the night sky is dominated by emptiness. The spaces between stars seem wide, the distances unimaginable. But in the grand layout of the galaxy, even the most isolated star has neighbors, millions of them. The Milky Way's population density is surprisingly high for something often described as mostly empty. In a cosmic sense, it is bustling. Yet its busyness unfolds on timescales too slow for human senses to detect. A city where everyone walks in slow motion is still a city, just one with very relaxed residents. If you could step outside the galaxy and look back at it as a whole, a view we cannot have from our sidewalk position, you would see a grand spiral shape, graceful and sweeping. But inside where we live, those sweeping patterns break down into discrete points of light, each too far away to hint at the arrangement they collectively form. It's an interesting truth. We know the Milky Way is a spiral not because we can see it directly, but because we've collected hints, the way you might deduce the layout of a city from scattered street signs and the shifting angle of distant traffic. It's a puzzle assembled from fragments, every piece discovered from the sidewalk and then projected outward into a larger map. There's something comforting in this limitation. It means the sky we see is a local sky, familiar, intimate, a view shaped by our immediate surroundings. The Milky Way's full architecture is grand and magnificent, yet the tiny patch we inhabit feels personal, almost like a neighborhood we've grown accustomed to. We learn the bright stars first, the ones that stay fixed in recognizable patterns. We notice how they move with the seasons, how they rise and set. Only later, with curiosity and perhaps a bit of imagination, do we consider that they are merely the closest lamps in an enormous district of light. And the city metaphor stretches even further. Just like urban centers thrive not because of a single building, but because of the collective hum of many structures, the Milky Way's beauty lies in the combined glow of its countless stars. Each contributes a fraction of the total light. Yet together they create the pale band that arcs across the sky on clear nights. It's a gentle reminder that even small lights, scattered across great distances, can create something extraordinary when they quietly cooperate. As we stand on our cosmic sidewalk, we remain unaware of most of the galaxy's wonders. But that unawareness is part of the charm. The mystery is slow and inviting, not meant to be solved in a night. The city of stars stretches far beyond our horizon, expanding in all directions, its deepest lights softened by unimaginable space. And perhaps, if galaxies had opinions, this is exactly how the Milky Way would prefer to be experienced. From the inside, where its immensity feels like a familiar, glowing neighborhood rather than a distant, overwhelming spectacle. If you could step back far enough, far beyond the edges of the Milky Way, far past the faint outer fringes where only a few wandering stars drift, you would see something unusual about our home galaxy. You'd notice that it isn't still. It turns, very slowly, gracefully, so gradually that you might suspect it of rotating only out of polite habit, like someone who continues stirring a cup of tea long after the sugar has dissolved. The galaxy's rotation is real and constant, but so unhurried that for the entire lifetime of every creature on Earth, it remains utterly undetectable. The Milky Way completes a single revolution in a span of time so vast that ordinary chronology dissolves. Hundreds of millions of years pass before it makes one full turn, a figure so large that counting it in Earth years feels almost mischievous. A single orbit lasts longer than the rise and fall of mountains, longer than the existence of entire species, longer even than the rearrangements of continents. It is a scale of motion that makes human history seem like the brief flicker of a firefly. And yet, we are all participating in that enormous rotation, carried through space without the slightest jolt or vibration. On Earth, movement is usually something you can sense. A car hums. A train shudders. An airplane nudges your spine with subtle changes in direction. Even gentle motions, like drifting on a raft or leaning into a slow swing, announce themselves through sensation. But our solar system glides along the galaxy's curve so quietly that not even the most sensitive instruments detect the motion directly. Instead, we infer it from the way nearby stars appear to drift over generations, like trees sliding past a window, so slowly that you begin to wonder if it's the trees that are moving, or the window, or perhaps a little of both. The speed of this journey is surprisingly swift by everyday standards, faster than any spacecraft, faster even than the orbiting stars appear to suggest. But because the distances involved are gigantic, that speed spreads itself thin across thousands of lifetimes. It becomes a kind of invisible motion, experienced but not felt. If the solar system had a dashboard, it would register a constant velocity, yet the passengers, including every creature that has ever lived, would remain blissfully unaware. There is something soothing about this, about knowing we are perpetually in motion yet never disturbed by it. The galaxy rotates with the calm assurance of an ancient wheel that has been turning since long before Earth formed. Its stars follow their curved paths like patient travelers who have accepted that the journey is the destination. Even the sun, often imagined as the center of its own system, is just another passenger on this vast, quiet ride. For the sun, this path through the galaxy is not a straight line but an elegant, looping route shaped by gravity's guidance. It moves in a wide orbit that takes it through regions of varying stellar density and subtle shifts in interstellar material. None of these regions introduces abrupt changes. There are no galactic potholes, no sharp turns, no sudden accelerations. The entire system glides with a steadiness that might make one suspect it takes pride in not disturbing its inhabitants. If a creature evolved the ability to detect the galaxy's rotation, it might spend its entire life waiting for something, anything to happen, only to discover that cosmic elegance often expresses itself by refusing to rush. There are stars that move faster and stars that move slower, each following its own trajectory in a kind of loosely choreographed dance. The sun, for its part, maintains a pace neither hurried nor lethargic, drifting through the galaxy like a modest traveler who doesn't mind staying somewhere for a few 100 million years before continuing on. The planets orbiting the sun might be compared to passengers sitting comfortably on a slow-moving boat, utterly unaware that the river itself is winding through a much larger landscape. This quiet movement has shaped the environment of our solar system in ways too gentle to notice. As we drift through different regions of the galaxy, the density of surrounding interstellar material changes, affecting the boundary of the sun's protective bubble, the heliosphere, which expands and contracts like a sleeping creature breathing slowly. But even this breathing is sublimely mild, altering nothing in our daily experience. If the heliosphere shifts by 1 billion kilometers, Earth continues spinning and orbiting without so much as a raised eyebrow. Perhaps the most comforting part of this immense motion is how harmless it feels. Human experience often associates movement with uncertainty or change. But here, at the cosmic scale, movement becomes a form of stability. The sun has followed its orbital path for billions of years, and it will likely continue without interruption for billions more. This rotation is not a journey from point A to point B. It is the galaxy's natural rhythm, as steady as a tide. A tide, however, that takes an entire geological epoch to roll in. If one were to imagine the Milky Way as a colossal wheel, among the many spokes would be our own solar system, holding its place not through rigidity, but through the balance of gravitational forces. And though the wheel turns without pause, every part moves in a state of graceful equilibrium. It is a reminder that motion does not always require noise or turbulence. It can be quiet, consistent, nearly invisible. And so we drift, Earth, Sun, planets, and moons, carried effortlessly around the galaxy. No one feels the turn, but we are turning all the same, participating in a rotation so immense and slow that it becomes a kind of stillness, a stillness measured across deep time, where movement and quiet are not opposites but companions. Trying to understand the shape of the Milky Way from inside it has always been a bit like trying to sketch the outline of a forest while sitting beneath its thickest canopy. No matter which direction one looks, branches stretch overhead, trunks crowd the view, and the larger structure, whatever form it might take, remains hidden. Astronomers spent centuries attempting to make sense of the galaxy's architecture, and for most of that time, their efforts were met with polite cosmic resistance. The Milky Way, for all its brilliance, is exceptionally good at obscuring its own design. Part of the problem is dust, interstellar dust, to be precise. It's not the dust that collects under furniture, though it shares the trait of being quietly inconvenient. This dust floats between stars in long, sinuous clouds, absorbing and scattering visible light. To early observers, it appeared merely as dark streaks on the sky, soft interruptions that looked deceptively ordinary. But in truth, these clouds were capable of hiding entire structures, veiling star clusters, and erasing vast sections of the galaxy from view. It was as if the Milky Way preferred privacy, surrounding itself with a sheer curtain of cosmic material that let only the brightest hints of its form shine through. Astronomers peered through this veil with whatever tools they had at the time. For centuries, their best instrument was simply the unaided eye, and with that alone, the Milky Way's shape appeared unknowable. It stretched overhead in a luminous band, too wide to be a mere streak, too irregular to be a perfect ring. Some imagined it as a flattened disk. Others suspected it might be spherical. A few considered the possibility that it was something stranger altogether, a kind of cosmic river or luminous archway. In the absence of clear information, creativity flourished. Even with the arrival of early telescopes, the picture hardly sharpened. Though stars became clearer and more numerous, the problem of perspective persisted. Because we sit inside the galaxy, every direction we look contains stars. Near ones, far ones, bright ones, dim ones, layer upon layer. It becomes difficult to tell which belong to the same structure and which merely overlap in line of sight. If the galaxy has majestic spiral arms, They do not announce themselves in neat curves when viewed from within. Instead, they appear as dense regions of stars, as though someone folded the sky gently and left it that way. For a long time, astronomers wrestled with the idea that the Milky Way might not be a simple disk. Observations revealed odd asymmetries, regions where stars seemed to cluster more intensely, areas where gas and dust formed unexpected shapes, stretches where brightness dimmed abruptly. Some scientists believed the galaxy had spiral arms. Others weren't convinced. The data was too ambiguous, too heavily filtered through the dusty atmosphere of interstellar space. It was like trying to deduce the layout of a vast garden by examining only the plants directly in front of one's feet. Gradually, hints began to accumulate. Radio astronomy opened new windows, allowing observers to trace clouds of hydrogen gas across the galaxy. Unlike visible light, radio waves slipped through interstellar dust with ease, revealing structures that had long remained hidden. Patterns emerged, arcs and loops, dense clusters arranged in broad, sweeping formations. These patterns suggested something familiar: spiral arms. But even then, the picture was incomplete. Some features refused categorization. Some curves were too subtle to map precisely. The Milky Way's spiral nature seemed likely, but the exact number, shape, and symmetry of the arms remained open to interpretation. Then came the question of a central bar, a linear structure of stars stretching through the galaxy's core, often found in spiral galaxies elsewhere in the universe. Did the Milky Way have one? Early evidence was contradictory. Some observations hinted at a bar. Others suggested a more rounded bulge. This disagreement continued for decades, with each new data set offering both clarity and complication, as though the galaxy itself enjoyed presenting mixed signals. Eventually, infrared observations confirmed the presence of a bar, but even then, its length, shape, and orientation proved difficult to determine. Modern data has improved the situation greatly, yet the Milky Way still resists becoming a simple diagram. Even now, researchers debate the exact details of its structure. Are there two major spiral arms or four? Are some arms genuine features or merely long, luminous bridges of star-forming gas? Does the bar twist gently as it rotates? The answers shift slightly with each new observation, each new satellite, each new processing technique. The galaxy is not a static object. It's a dynamic system in endless motion, reshaping itself over millions of years, making the question of its true shape a little like asking for the perfect still portrait of a waterfall. There's a quiet charm in this uncertainty. The Milky Way remains familiar, yet not fully mapped, a place we call home but do not entirely understand. Its shape is not a fixed blueprint, but an evolving portrait that becomes clearer only gradually, as though painted one soft stroke at a time. The galaxy allows us glimpses of its structure, spiral hints, central elongations, swirling regions of gas, but it never reveals everything at once. Perhaps that's fitting. After all, we are creatures living inside a grand system far too vast to hold in the mind all at once. Our perspective is local, our view partial, and our understanding assembled patiently from fragments. The Milky Way does not hurry us. It seems to invite slow discovery, rewarding curiosity with gentle revelations. And in that slow unfolding, the galaxy's shape becomes not just a scientific puzzle, but a reminder that even familiar places can hold mysteries that take time to appreciate, especially when seen from the sidewalk rather than from above. When people first began to chart the sky, the Milky Way's bright stretches naturally commanded attention. They glittered softly across the night like pathways of scattered embers, but just as striking, if one paused long enough to notice, were the dark streaks interrupting that glow. These weren't simply shadows or blank spaces where the galaxy forgot to shine. They were something far more intriguing, gentle silhouettes of cold material drifting in space. Their darkness wasn't the absence of light. It was the presence of something dense enough to hide whatever lay behind it. To the unaided eye, these lanes appear as quiet intrusions, like strokes of charcoal brushed across a luminous canvas. They slip between star fields with a subtle confidence, neither dramatic nor timid. Their beauty comes from understatement. Even now, with all we know, it can be hard not to look at those dark spaces and imagine them as empty, as though the galaxy had left gaps for reasons known only to itself. But these shadows are some of the most crowded places in the Milky Way. Crowded not with stars, but with the raw ingredients from which stars will eventually be made. The material inside these dusty lanes is delicate. Tiny grains, molecules, wisps of gas. They float together in enormous structures that span dozens or even hundreds of light years. Although the particles composing them are minuscule, smaller than grains of smoke, they accumulate into great sweeping clouds. They form filaments, knots, and broad sheets, all held in place by gravity and the gentle motions of interstellar gas. The result is a kind of cosmic weather system, though one that changes with glacial slowness. Nothing in these lanes hurries. Everything drifts. The darkness arises because the dust is exceptionally good at absorbing visible light. When starlight tries to pass through, much of it simply doesn't make it. Longer wavelengths like infrared slip through more easily. But to human eyes, the lanes appear as opaque silhouettes. In this way, they act like curtains pulled across distant windows. Behind them, countless stars glow quietly, unseen but still present. The lanes are not interruptions, they are veils. And behind each veil lies a landscape where future stars slowly gather their strength. Inside these dense clouds, the temperature falls to levels colder than any place on Earth. The gas moves lazily, molecules drifting without destination. Over immense spans of time, gravity begins to nudge certain regions slightly closer together. These nudges become tugs, and the tugs become slow collapses. It is in these secluded recesses, hidden inside the dark, that stars begin their long formation. The earliest stages of a star's life are almost comically quiet. A small pocket of gas starts to clump, barely noticeable against the backdrop of the cloud that surrounds it. It grows heavier, pulling in more material, folding inward with patience that borders on stubbornness. Nothing flashes. Nothing ignites. For millions of years, these forming stars remain cocooned, wrapped in layers of dust that keep their faint beginnings hidden from prying eyes. If galaxies had a nursery, this would be it. A place where creation is not announced, but whispered. Occasionally, astronomers observe these regions in light that can slip through the dust, infrared, millimeter, radio. Through these longer wavelengths, the obscuring clouds reveal their internal textures. Long filaments twist gently like strands of smoke suspended in still air. Clumps appear like knots tied long ago and left to tighten gradually. Sometimes, entire star clusters are found forming together, each young star emerging from its own sheltered pocket, like lanterns being lit behind thick curtains that slowly become translucent as the lanterns grow brighter. These dark lanes give the Milky Way much of its character. Without them, the galaxy would appear flatter, less textured, its glowing regions too uniform. The dark lanes create contrast, depth, and a kind of visual humility. They remind us that a galaxy is not simply a luminous spiral, but a living system with cycles, bright stars aging and fading, and new ones waiting quietly in the shadows before stepping forward. There's a subtle humor in the idea that some of the most active regions of the galaxy appear, to our eyes, utterly muted. It is as though the Milky Way carries out some of its most important work in a room with the lights off. These places where stars are born do not advertise themselves with brilliance. They do not sparkle or flare. Instead, they appear as gentle absences, dark patches that might be mistaken for blank space by a casual observer. The galaxy seems to favor the slow reveal, allowing its brightest citizens to emerge only when they are ready. Even after a young star grows hot enough to shine, it often remains hidden beneath its dusty cocoon a while longer. Only when its light becomes strong enough to push away or heat the surrounding material does the cloud finally part, exposing the new star to the wider galaxy. By the time this happens, the lane it formed within may have shifted, thinned, or drifted apart, subtly reshaped by the very stars that were born inside it. In the grand sweep of time, these dark lanes change the galaxy as surely as rivers shape continents. They are reservoirs of possibility, places where future generations of stars, and perhaps planets and life, wait in potential. Their darkness is not a void, but a promise, a quiet prelude to light that will one day emerge. And so the Milky Way's dark lanes remain one of its softest mysteries. Silent, shadowed regions that hold more substance than their dimness suggests. They are gentle reminders that not all creation arrives in brilliance. Sometimes it begins in stillness, under a veil, in places that appear empty until one learns how to see. Deep inside the Milky Way, far beyond the familiar ribbon of stars that stretches across our sky, lies a region that moves at a different pace from the rest of the galaxy. The closer one drifts to the center, the more densely packed the stars become, like lanterns gathering toward a silent hearth. Though we cannot see this heart with our eyes, it pulses with a kind of ancient steadiness. It is a place where time feels thick, not hurried or restless, but weighted with the long memory of the galaxy itself. And at that center, resting with enormous gravity and even more enormous patience, is a supermassive black hole. To call it supermassive is simply a way of acknowledging that it contains millions of times the mass of our Sun. But these numbers, impressive as they are, fail to capture its presence. The black hole at the galaxy's core, known to astronomers as Sagittarius A, is not a dramatic monster lurking in the dark. It is quiet, almost reserved. It does not churn violently or devour everything nearby. Instead, it sits at the center like a stone in a smooth river, shaping the flow around it with subtle, dependable influence. Being so far from Earth, it poses no threat. Even if it possessed a personality, it would likely be too busy minding its own deep-time business to take any interest in planets orbiting a modest star halfway across the galaxy. The distance between us and the center is immense, tens of thousands of light years, a stretch so long that the sunlight touching your skin today will have faded into cosmic background noise long before its echo could reach that core. Whatever happens there, it happens in its own quiet realm, far removed from our immediate concerns. The environment surrounding the black hole is busy in its own slow-motion way. Stars orbit it at remarkable speeds, though even these speeds unfold gently across human lifetimes. These stars move in tight arcs, tracing elegant paths around the core, pulled by gravity that is strong yet composed. Observing them reveals the black hole's presence, not through violence, but through precision. Their orbits follow lines carved by an invisible mass, much as leaves on a pond circle a stone resting beneath the surface. It is tempting, because of popular imagination, to think of black holes as chaotic or hungry. But Sagittarius A behaves more like a minimalist. It consumes very little, radiates faintly, and prefers a low profile. Most of the matter that drifts near it simply orbits, forming slow, curving streams of gas and dust that glow softly in infrared and radio wavelengths. These streams trace patterns that look almost contemplative, swirling with a patience that suits the environment. Even the light near the center seems to respect the pace. Radiation emerges in gentle pulses, not flares. The region flickers occasionally, but never with urgency. Observations show glimmers that brighten and fade, like embers shifting in the draft of an unseen breeze. To watch the galactic center is to witness power expressed with restraint. Gravity so intense it shapes the galaxy, yet so peaceful in its outward appearance that it often goes unnoticed unless one looks carefully. The black hole itself does not shine. Its presence is known only through the way space behaves around it. Even nearby stars, brilliant in their own right, appear humble in comparison to the mass they orbit. These stars are among the fastest in the galaxy, yet their speed feels less like haste and more like compliance with a very old rule, one established long before the sun was born. They follow paths laid down by the central mass, not as captives, but as participants in a gravitational choreography that has persisted for billions of years. Around the core, interstellar gas gathers in faint filaments and large looping arcs. These structures twist gracefully, shaped by magnetic fields and the slow dynamics of the region. The black hole's influence extends far beyond its immediate surroundings, helping anchor the galaxy's overall structure. The stars in its vicinity, old and young alike, move in patterns that reflect the central gravity well, lending the core a sense of order rather than chaos. Even the history of this region unfolds without theatricality. The black hole did not erupt into existence in a moment of cosmic spectacle. It formed gradually, through the accumulation of matter and the collapse of massive stars long ago. Over time, it grew into the anchor we now know, a gravitational center that serves as the galaxy's quiet fulcrum. And it has stayed there ever since, neither wandering nor wavering, keeping its position with effortless assurance. One might think that a black hole with millions of solar masses would dominate its surroundings with dramatic flair. But Sagittarius A seems uninterested in theatrics. Its stability is part of its nature. It offers no sudden surprises, no catastrophic changes, no demands on the galaxy beyond the soft insistence of gravity. In many ways, it behaves like the calm elder at the center of a sprawling family, one who doesn't speak often, but whose presence provides structure simply by existing. If the galaxy could express gratitude, it might thank its central black hole for keeping things in place. The spiral arms sweep around the core. The stars orbit in vast loops. Gas clouds follow paths shaped by its gravity. And all the while, the black hole remains silent and steady, content to anchor the system without complaint. The galactic center is not a place of danger for us. It is a place of origin and balance, a region that has shaped the Milky Way's history with quiet influence. From its distant vantage point, it watches the galaxy turn, slowly, steadily, without hurry. And in its long patience, the black hole reminds us that cosmic power does not always roar. Sometimes it rests, unmoved and unbothered, holding everything together with a gravity so ancient and gentle that it feels like the universe's version of calm breath. If you try to imagine the solar system completing one full trip around the Milky Way, the mind quickly realizes it is being asked to stretch far beyond its usual limits. Human beings measure time in breaths, in heartbeats, in the soft stepping of days. We measure years in the turn of seasons, and centuries in the memory of civilizations. But a galactic year, one single orbit of the Sun around the Milky Way, requires a span so vast that ordinary timekeeping simply dissolves. 225 million years is the kind of number that resists staying in the mind. It drifts away as soon as you try to picture it, like mist slipping through fingers. And yet, here we are, drifting through the galaxy as part of that immense journey. The Earth has traveled through only a small fraction of its current galactic orbit since the earliest humans appeared. In the time between the rise of mammals and the present day, the solar system has completed only a fraction more. If the Sun's long path were a giant track, we'd still be somewhere in the early laps of our existence. Not because the journey began recently, but because the circuit is so overwhelmingly large. To put the scale in gentler terms, imagine the Sun carrying its family of planets along a road that curves so subtly you could walk beside it for 1,000 lifetimes. and never notice the bend. This road is not paved with stone or dust, but with interstellar space, quiet, expansive, serene. The solar system travels along it at a speed that would seem breathtaking by any human standard. Yet the journey is so long that even at such speed, one revolution around the galaxy is less of a completed loop and more of an ongoing drift. If Earth had kept a diary since its earliest days, noting each major chapter of its geological history, it would read more like the logbook of a traveler cataloging landmarks along a route far bigger than itself. When the first oceans formed, the solar system was in a completely different region of the galaxy. When the earliest plants began to green the continents, we were somewhere halfway along another stretch of the curve. The dinosaurs lived their entire 160 million year era without seeing the sun return to the same galactic neighborhood twice. By the time their chapter ended, the solar system still hadn't finished a single orbit. This is the kind of timescale that encourages perspective. It suggests that the idea of once around might not be particularly relevant to creatures who live in spans of decades. The sun completes its orbit without fanfare, without markers or milestones. It doesn't pause at a finish line and turn to begin another lap. The journey is continuous, seamless, and so slow from our point of view that it becomes indistinguishable from stillness. If someone told the sun that it was halfway around the galaxy, the sun might respond, if suns were capable of commentary, with a gentle hum, as though acknowledging that halfway is a pleasant idea, but not especially meaningful. As we accompany the sun on this long trip, we pass through different regions of interstellar space. These regions are not dramatic or hazardous. They are simply variations in density, temperature, and radiation. Some are more crowded with drifting gas, others are nearly empty. Occasionally, we pass near clusters of stars, watching their light shift slightly across the ages, though never fast enough to suggest motion in any immediate sense. The journey itself is not marked by events, but by a slow, ongoing change in surroundings too subtle for human eyes to detect. The solar system's route is gently inclined relative to the galaxy's main disk, causing us to drift slightly above and below the plane over long stretches of time. This vertical oscillation, like the rising and falling of a slow tide, is another reminder that even enormous motions can occur quietly. We cross the galactic plane every tens of millions of years, though Earth has no sense of crossing anything at all. There is no line, no sign, no indication, only continuation. The galaxy does not rush us. It does not require us to finish our orbit in a specific time frame. If the sun were to speed up or slow down slightly, which it does, depending on gravitational influences, there would be no consequence beyond mild changes in its path. Galactic orbits are not precision engineered. They are broad, sweeping curves shaped by the overall mass distribution of the Milky Way. Each star has its own orbital period, its own route, its own slow arc, and all these arcs weave together into a system that appears, from a distance, beautifully organized. If someone living on Earth tried to contemplate the idea of returning to the same point in the galaxy, they would discover something peculiar. By the time our solar system returned to the location it once passed, the galaxy itself would have changed. Stars migrate slightly. Clouds dissipate and reform. New stars ignite. Old ones fade. The region through which we once drifted may no longer resemble itself at all. A galactic year is long enough that returning to a familiar place becomes impossible. The familiar place itself has moved on. Perhaps that is why the sun's journey feels so calm. There is no destination, no arrival point, no sense that the orbit needs to be completed. The motion is steady and ongoing, more poetic than purposeful. We are passengers in a system that drifts through deep time with unhurried grace. And in that drift lies a quiet comfort. It means that life on Earth, brief and intricate as it is, unfolds during a small, gentle moment in a journey too large to grasp. We participate in the galaxy's motion simply by existing, carried along through the stars, without any need to notice the path or measure the distance. It is movement without urgency, progress without deadline, an orbit that asks nothing of us and offers, in return, the subtle reassurance that not all cycles need to fit within the span of a human story. If the Milky Way were a grand, luminous city, full of glowing neighborhoods and gentle swirls of starlight, then its halo would be the outskirts where few ever wander, quiet, sparse, and stretching far beyond what most residents would imagine as the city limits. It is a region that exists almost in secret, not hidden by intention, but by faintness. Where the galaxy's spiral arms create sweeping forms rich with motion, the halo drifts in near silence. It is wide, nearly spherical, and made of material so subtle that one might suspect it of trying not to be noticed. The halo contains stars, but not many, at least not compared to the star-filled disk we inhabit. The ones that do reside out here tend to be ancient, some among the oldest stars in the galaxy. They shine with a subdued light, as though remembering times when the Milky Way was young and more chaotic, when collisions with smaller galaxies shaped its early structure. These halo stars drift in long, looping orbits that carry them far above and below the familiar plane where most stars live. Their paths are not circular arcs like those of the sun, but stretched and elongated, like slow comets moving on grand, winding journeys that take hundreds of millions of years to complete. Most galaxies have halos, but halos do not behave like the luminous parts we readily picture. They do not glow with the dense radiance of spiral arms, nor do they offer the dramatic silhouettes of dust lanes. Instead, they are airy, diffuse, and patient. The halo does not press close to the galactic plane. It seems content to remain where it is, distant, observant, perhaps a little aloof. It's a region that asks very little. The halo never gets crowded. Its stars rarely approach one another, and when they do, their encounters are gentle and brief. These stars have had billions of years to adjust to their solitary orbits. They keep to themselves in a vastness that offers all the elbow room one could ever want. If the galaxy's disk is a bustling marketplace of swirling gas and starlight, the halo is more like a high, open plateau beneath a quiet sky. Adding to this stillness is the presence of dark matter. Though invisible, it forms the scaffolding that holds much of the halo together. Dark matter doesn't shine, scatter light, or leave trails. It does not react to being observed. It simply exists, providing mass that influences the motion of stars and the gravitational shape of the galaxy. It extends well beyond the luminous halo, forming an even larger, unseen sphere. In this sense, the halo is not just faint, it is faint wrapped in something fainter still. The relationship between the halo and the rest of the Milky Way is subtle. The halo does not participate in the spiral structure. It does not help shape the galactic disk's familiar flatness. Instead, it serves as a kind of quiet boundary, a surrounding shell that stabilizes the galaxy's overall gravitational form. The stars within it orbit not in organized patterns, but in orientations that seem almost random, a reminder of ancient interactions long since faded into the background. Many halo stars arrived from elsewhere. Long ago, the Milky Way absorbed smaller galaxies, and their stars were gradually strewn across the halo like embers blown from an earlier fire. These remnants move in surprising directions, some against the rotation of the disk, some in steep inclinations, as though each carries a faint signature of the system it once belonged to. They don't blend perfectly, but that is part of the halo's charm. It is a place of quiet diversity, where each star pursues its own timeless route. Globular clusters, the dense spheres of tightly packed stars, also reside in the halo, circling the galaxy like distant satellites. These clusters are among the oldest structures we know, each containing hundreds of thousands of stars bound together by gravity in a compact knot. They move serenely through the halo, their orbits slow and stately. If the halo is a wide, tranquil field, then globular clusters are ancient trees, their roots in deep time, their branches holding stars that have shared the same neighborhood for billions of years. Because the halo is faint, its presence is often overlooked in visual representations of the Milky Way. Artists love to depict the spiral arms and the glowing disk, but rarely do they draw the subtle shell surrounding it. This omission is not intentional. The halo is simply too gentle to portray easily. You can't sketch quietness or sparsity or the spaces between things. But the halo is there, embracing the luminous parts of the galaxy with a kind of understated grace. If one could float out into this halo, ignoring the minor inconvenience of needing to survive in a vacuum, it would be a remarkably peaceful place. The stars would appear few and far between. The galaxy's central glow would stretch beneath, broad and faint, like the soft light of an impossibly distant city. The vast emptiness would not feel hostile, only spacious. Movement would be slow. Change would be rare. Time itself might seem to loosen its grip. The halo does not demand attention, nor does it strive for beauty. Yet, in its quiet way, it contributes a sense of completeness to the Milky Way. It is the galaxy's soft boundary, the region where structure fades into openness, where stars wander without haste, and where the ancient remnants of cosmic history drift in long, unbroken arcs. And in its thinness, its faintness, its gentle remoteness, the halo reminds us that not every part of a galaxy needs to shine to matter. Some regions hold their significance in silence, keeping their distance while helping maintain the balance of everything within. Every galaxy carries a history, but the Milky Way's is not preserved in archives or timelines. Instead, its past drifts through space in long, fragile strands. Stellar streams curling like ribbons, clusters stretched into threads, and distant remnants moving in patient orbits that whisper of events so old they feel almost like geological memory rather than cosmic record. Nothing about these traces suggests conflict. They are not scars of violence in the dramatic sense, but gentle rearrangements, the kind that occur when large systems glide past one another, interacting over spans so long that even the word encounter feels too abrupt. These streams form when smaller galaxies or star clusters wander close enough to the Milky Way to be slowly tugged apart by its gravity. Not suddenly, but gradually, as if the larger galaxy simply sighs and the smaller one unfurls into a trail. Over hundreds of millions of years, stars that once lived together disperse, leaving behind arcs that loop around the galaxy in wide, quiet sweeps. They stretch across the sky with a delicacy that belies their immense scale, thin as threads of frost on a window pane. One such stream might contain thousands of stars, all drifting in unison, as though rehearsing a slow ballet choreographed by gravity itself. They move along curved paths that trace the roots of their long dissolution. From Earth, these stars are faint and scattered, and it takes careful observation to recognize their shared origin. Yet once recognized, they reveal themselves as unmistakable signatures of the galaxy's evolving structure, evidence that the Milky Way has been collecting neighbors for billions of years, not through force but through the gentle persuasion of its gravitational field. The stars in these streams are often older than most in the galactic disk. Their ages lend a quiet dignity to their motion. Like travelers who have wandered for so long, they no longer recall where their journey began. Some streams wrap around the galaxy multiple times, creating overlapping layers that resemble soft rings of smoke blown into a still room. Others are more scattered, irregular, hinting that their parent clusters disintegrated unevenly, giving way to a formation that looks more like drifting ash than a coherent arc. Closer to the outer halo, remnants of absorbed dwarf galaxies follow elongated orbits that take them far above and below the disk. These remnants, though sparse, are meaningful. They show that the Milky Way grew not through abrupt changes, but through quiet incorporations spread across deep time. A small galaxy might approach, linger nearby for 1 billion years, and then gradually lose its stars, contributing them to the halo or to streams that eventually blend into the larger galactic context. There is no rush. The process unfolds at a tempo set by gravity's soft patience. Some of the most graceful of these structures are the tidal tails, long extensions of star clusters stretched thin by the galaxy's pull. A cluster may start as a compact, spherical gathering of stars, all born from the same cloud in the same era. But over great spans of time, gravitational nudges elongate it, pulling stars outward in opposite directions. The result is a shape that appears almost like a celestial hourglass laid sideways, its center still intact, and its tails drifting outward like slow-moving currents. These tidal tails hold stories of origin, composition, and age. The stars within them share similar chemical signatures, almost like a faint family resemblance. Astronomers read these signatures to understand which clusters these stars once belonged to and what kind of environments they formed in. But the stars themselves do not carry these histories with any sense of burden. They move along their inherited paths with ease, content to shine quietly as they follow the gentle curves carved for them. Even the Milky Way's thick disk, the broader, more diffuse region above and below the main plane, carries traces of the galaxy's history in its motions. Some stars in this region move in slightly tilted orbits, suggesting that ancient interactions once jostled the galaxy enough to thicken its midsection. Yet even these motions are smooth and steady. Nothing in the thick disk looks abrupt. Everything seems softened by time. The galaxy's past is also written in the slow oscillations of stars that bob above and below the disk, like particles riding a long, shallow wave. Their motions reflect the overall distribution of mass in the Milky Way, including the contributions of both visible and invisible components. These vertical movements are subtle, a kind of memory stored in motion rather than matter. Over millions of years, stars rise gently, linger, then drift downward again, tracing cycles that began before humanity's earliest ancestors existed. In this way, the Milky Way preserves its history not in static records, but in the ongoing choreography of its stars. Each stream, each stretched cluster, each tilted orbit is a sentence in a story written across space rather than time. And though we often imagine galactic history as turbulent or dramatic, the evidence suggests something much calmer. A series of slow minglings and gentle absorptions, spread out so thoroughly that no single moment stands out as an event. Everything blends into the steady flow of deep time. Even now, new streams are forming. Small galaxies continue to orbit the Milky Way, some destined to be gently undone over eons. And as they do, the galaxy grows not by leaps, but by quiet accumulation. Its history unfolds in motion, soft, continuous, unhurried. A history that reminds us that change does not always need to be sharp to be profound. Sometimes it can simply drift, shaping the future with the lightest of gravitational touches. If you imagine the Milky Way going about its business in the quiet of cosmic space, you might picture it alone, spinning serenely with no need for company. But even a galaxy as large and self-contained as ours has neighbors, small, drifting companions that keep a respectful distance while sharing the same vast surroundings. These neighboring galaxies do not arrive with fanfare. They do not crowd or jostle. They come as soft presences, drifting at the edges of our gravitational influence with the kind of polite restraint one might expect from distant relatives who prefer not to intrude but still enjoy a quiet visit from time to time. The closest of these companions are dwarf galaxies, much smaller and much dimmer than the Milky Way. Some contain only a few million stars, a modest population compared to our galaxy's hundreds of billions. But their smallness does not diminish their charm. They wander around us with great delicacy. stretched into elongated shapes by our gravity, or compressed into compact clusters that resemble faint lanterns hung far out in the galactic twilight. Among the most well-known are the Magellanic Clouds, the Large Magellanic Cloud, LMC, and the Small Magellanic Cloud, SMC. To the unaided eye in southern skies, they appear as soft smudges of light, like two gentle brushstrokes left by a careful hand. These galaxies orbit the Milky Way, though orbit may imply more precision than the situation warrants. Their paths are long and somewhat meandering, influenced not only by our gravity, but also by each other's. They drift through space like traveling companions, who sometimes walk side by side and sometimes wander slightly apart, but always remain loosely connected. The interactions between the Magellanic Clouds and the Milky Way are subtle. Tidal forces create delicate streams of gas trailing behind them, a kind of cosmic wake that traces their motion across the centuries. These streams are enormous, but their structure is so diffuse that only sensitive instruments reveal them. Observed closely, they resemble soft, flowing ribbons, stretched patiently by gravity over millions of years. Nothing about these patterns suggests haste. They evolve slowly, weaving their way through space like long, drifting threads unraveling from ancient fabric. Beyond the Magellanic Clouds, other dwarf galaxies linger farther out. Some are spherical, compact, and faint. So faint, in fact, that they remained unnoticed until modern instruments found them half-hidden among dense star fields. They orbit the Milky Way on long, looping paths, often tilted at angles that give no hint of order. Each orbit can take billions of years to complete, which means many have not yet finished a single revolution since the galaxy itself was young. Their interactions with us are more like gentle exchanges of gravitational influence than true meetings. Occasionally, one of these dwarfs drifts a bit too close. But even then, the word close is misleading. In galactic terms, close means within a few 100,000 light-years, a distance so vast that even the fastest light takes centuries to cross it. At such distances, interactions unfold with unimaginable slowness. If two galaxies were to collide, the process would not resemble an impact. There would be no crash, no sudden flare, no cataclysmic upheaval. Instead, the encounter would be more like two expansive clouds blending, their stars passing by one another with plenty of room to spare, their shapes distorted gradually over millions upon millions of years. The idea of a galactic collision often conjures excitement or drama, but in quiet truth, these encounters are among the most patient events in the universe. Stars rarely collide during such minglings. They simply adjust their orbits, drifting into new configurations as the galaxies merge. In this sense, a collision is less like an accident and more like two large flocks of birds interweaving, changing formation, sharing space for a while, and eventually settling into a new pattern. The process is slow enough that a civilization could rise and fall without noticing any change at all. Some dwarf galaxies are only temporary visitors. They pass by on long trajectories that will eventually carry them out of the Milky Way's influence. Others are bound to us, following paths that will keep them nearby for as long as the galaxy exists. A few seem uncertain, their motions difficult to categorize. Perhaps companions, perhaps wanderers, perhaps something in between. The universe allows for ambiguity, and these small galaxies move accordingly. Their subtle presence adds texture to the region surrounding the Milky Way. Without them, our galaxy would seem more isolated, a solitary island in a dim sea. With them, there is a sense of quiet company, of neighbors who do not intrude but whose existence hints at a larger community. They remind us that galaxies rarely travel alone. Even the largest systems tend to gather companions, forming loose families that evolve together across cosmic time. These interactions have shaped the Milky Way in their own understated way. Streams of stars in the halo trace the remnants of companions absorbed long ago. Patterns in the galaxy's outer regions reflect the tug of smaller galaxies that passed by or settled into orbit. The history of these encounters is not recorded in dramatic signatures, but in slight shifts, faint trails, and gentle distortions. To look out at these neighboring galaxies is to witness the soft social life of the cosmos. Everything moves, but nobody rushes. Everything interacts, but nothing shouts. The dwarfs drift patiently, their motions measured in billions of years, bringing with them no urgency, no conflict, only the quiet gravitational conversations shared between companions wandering through the same expanse. In their presence, the Milky Way feels less like a lone traveler and more like a participant in a slow, courteous waltz, each step measured in eons, each turn a reminder that even in the vastness of space, nothing exists entirely alone. When people imagine the Milky Way, they usually picture its bright parts, the grand spiral arms, the star-rich central region, or the soft glow of the disk stretching across the night. Light draws our attention, after all. We notice the luminous, the radiant, the visible. But the galaxy's most influential component is the one that refuses to shine. Most of the Milky Way's mass, by far, comes from something we cannot see directly at all: dark matter. It doesn't glow. It doesn't reflect. It doesn't warm. It simply exists, softly and steadily, shaping the galaxy with a presence that feels almost self-effacing. Dark matter is often described by what it is not. It is not made of the same particles that form stars or planets. It is not the dust that drifts between stars, or the gas that forms new generations of suns. It is not the faint glow of the halo, nor the bright swirl of the spiral arms. If the Milky Way were a stage, dark matter would be the invisible frame holding up the scenery, a structure that determines how everything moves, even though no one in the audience can see it directly. Astronomers first suspected dark matter existed because of motion. The stars in the galaxy's outer regions were moving too quickly to be held in place by visible matter alone. According to the gravity from all the stars, gas, and dust we could detect, those outer stars should have drifted away like leaves escaping a loose breeze. Instead, they remained anchored, orbiting steadily, as though tied to an unseen mass. Something was contributing gravity, something large, widespread, and silent. This unseen substance envelops the Milky Way in a vast spherical halo that extends far beyond the limits of the luminous parts. Earlier chapters explored the faint halo composed of ancient stars, but the dark matter halo reaches much farther still. It is the galaxy's soft outer coat, fluffier than any visible component and far more massive. It does not form disks or spirals. It does not cluster into shining shapes. It occupies space gently, like a diffuse cloud that respects personal boundaries, but nonetheless influences everything around it. Dark matter's most important role is simple. It keeps the galaxy together. Without it, the spiral arms would not hold their form. The stars moving along the outer edges would drift away into intergalactic space, gradually unraveling the elegant structure we know. Dark matter provides the extra gravity that binds the Milky Way into a coherent whole. It acts not like a clasp or a chain, but more like a soft, omnipresent pressure, gentle yet necessary. Because it doesn't emit or absorb light, dark matter is not intrusive. It's the kind of presence that contributes stability without seeking recognition. If it had a personality, it might be the quiet caretaker who sweeps the floors and oils the hinges after everyone has gone to bed, ensuring the building stands firm through the seasons. In fact, most of what the Milky Way does, its rotation, its shape, its long-term cohesion, relies on the consistent gravity supplied by this invisible majority. The idea of an unseen substance shaping the galaxy might feel mysterious, but the mystery is of a calm kind, not a troubling one. There is no drama in its existence. It does not flare or consume or collapse. It does not interact with light at all. Its influence is expressed only through gentle gravitational guidance, encouraging stars to follow particular paths, helping clusters remain bound, and giving the galaxy a mass it would otherwise lack. Even though dark matter stays hidden, we get glimpses of its distribution through the motions of stars. These motions serve as quiet tracings, like ripples on a pond, revealing the shape of something resting beneath the surface. In regions where more dark matter resides, stars orbit a little faster. Where there is less, the speeds ease slightly. These changes are subtle, detectable only through long-term measurement, but consistent enough to show the pattern of the invisible halo that surrounds us. It's important to note that dark matter does not gather densely like ordinary matter. It seems content with wide spacing, spread out across vast distances. There are no dark matter stars, no dark matter planets, no dense clumps casting secret shadows. It prefers a gentle uniformity. If it were a sound, it would be a low, steady hum, felt more than heard. Its distribution creates a kind of quiet scaffolding, shaping the galaxy without seeking to be shaped by it in return. For all its influence, dark matter's nature remains largely unknown, but the Milky Way has been living with it for billions of years, and the relationship is notably peaceful. There are no abrupt changes caused by it, no restless motions. Dark matter does not distort the galaxy with sudden impulses. Its gravity is constant, smooth, long-lasting. Were the galaxy to write its own autobiography, dark matter would be the long chapter describing a reliable companion who has been there since the beginning, steady, understated, and essential. In a way, dark matter offers a kind of lesson in gentleness. It reminds us that something can be powerful without being loud, essential without being obvious, influential without taking center stage. Its presence allows the Milky Way to spin with elegance and stability. Without it, the galaxy would be looser, less coherent, perhaps unable to sustain its familiar structure. And so, while stars dazzle and nebulae glow and black holes anchor, dark matter hums quietly in the background, shaping everything without ever announcing that it is doing so. The galaxy moves as it does because of this unseen majority, an invisible partner guiding the Milky Way's slow dance through space. If the Milky Way had a voice, it would not be a loud one. It would not thunder or echo. It would not carve its presence into the silence of space with anything so abrupt as a shout. Instead, its sound, if such a thing could exist in the vacuum, would be a kind of near silence, a hush shaped by motion, vibration, and the faintest whisper of radiation. Nothing in the galaxy produces noise in the way we experience it on Earth. Sound, after all, needs air or water or some medium to ripple through. But the galaxy is full of rhythms, and though they do not travel as audible waves, they form patterns that invite interpretation. Listening to the Milky Way means imagining how movement itself might feel if it were translated into something like sensation. Every star vibrates, not in the dramatic sense of a ringing bell or a plucked string, but in the soft, exploratory tremors of hot gas shifting under the star's own gravity. These vibrations cause the star to brighten and dim in rhythms so gradual they resemble breath rather than motion. In the sun, these vibrations create pressure waves that ripple from the core outward, shaping subtle undulations on its surface. If one could hear these oscillations translated into sound, they would resemble low, sustained tones, layers of gentle hums stacked like chords played on an instrument with no beginning or end. Across the Milky Way, billions of stars produce their own versions of these quiet pulses. Most are too faint, too distant, too gradual for any single pattern to stand out. But taken together, they form a collective rhythm that might, in imagination, resemble a background murmur too soft to notice unless one were paying careful attention. Like the faint pressure in the air at dusk, it would be something felt rather than heard. Then there are the radio waves. Though silent to human ears, they drift through space like long, slow swells, messages not intended as messages, carrying information by virtue of simply existing. Pulsars, for instance, emit beams of radiation that sweep across space like cosmic lighthouses, creating regular pulses detectable from enormous distances. These pulses are astonishingly precise. Some tick with steadiness that rivals the best human-made clocks, sending out beats that, if transformed into sound, would resemble a steady metronome in a vast, empty hall. Yet even these pulses, impressive as they are, would not disturb the galaxy's overarching quiet. They are accents, not declarations. Most radio waves come from cooler clouds of gas, from the soft flickering of electrons shifting in magnetic fields, from faint emissions of atoms transitioning between energy states. Translating these into sound would produce long, drawn-out tones that shift slowly over time, more like sustained drones than melodies. Meanwhile, gravity produces its own version of rhythm. When massive objects move, stars orbiting gently, clusters drifting on ancient paths, their motions alter the fabric of space in ways so subtle that only the most sensitive instruments can detect the changes. These are gravitational murmurs, ripples far gentler than the dramatic waves produced by colliding black holes or merging neutron stars. In the calm galactic environment, these gentle shifts resemble the slow rising and falling of an unseen tide. If these gravitational patterns could be rendered as sound, they might take the form of deep, nearly inaudible notes, tones below the threshold of hearing, more like vibrations one becomes aware of through the bones rather than through the ears. They would not come in beats or bursts, but in long, continuous stretches that change with glacial patience. Even interstellar dust, drifting in clouds across the galaxy, contributes a texture to this imagined soundscape. Dust grains, warm and cool, emit faint infrared radiation and clump together in structures that shift imperceptibly over time. Their contribution is not rhythmic, but atmospheric. In sonic terms, they would add the softest layer of static, not noise in the chaotic sense, but a gentle background fullness that suggests space is not empty, but filled with quiet potential. Across the galaxy, magnetic fields twist and coil in complex patterns, guiding charged particles along looping paths. These movements produce faint emissions that, if converted into audio, would create slow, warbling tones. Subtle, wavering frequencies reminiscent of wind passing across the openings of distant caves. The fields are not uniform. They vary from region to region, creating a patchwork of quiet currents. Listening to them would be like hearing long threads of sound woven into a tapestry too large to grasp all at once. In the absence of air, none of these phenomena create literal sound. But the galaxy is full of motions that suggest the possibility of a cosmic soundtrack, one made not of sharp notes or sudden changes, but of sustained harmonies. It would be the kind of soundscape that encourages stillness, not attention. A background presence that makes itself known only through patience. If someone could drift in space, unprotected but somehow unharmed, and simply listen with senses attuned beyond hearing, they might experience the Milky Way as a layered vibration, the low hum of stellar tremors, the steady ticking of distant pulsars, the sweeping drones of radio emissions, the deep gravitational undercurrent, the faint static of dust. All of it blending into a single continuous tone, neither loud nor quiet, neither rising nor falling, a cosmic hush that simply is. This imagined sound is not an intrusion. It is a presence, something that suggests the galaxy is alive with subtle motion, even in its silence. A reminder that stillness is rarely absolute, that even in the deepest quiet, there are patterns, pulses, and rhythms waiting beneath the surface, felt rather than heard, steady as the galaxy itself. For as long as human beings have lifted their eyes toward the dark, the Milky Way has been there, quiet, steady, and patient. Long before we understood what it was, long before telescopes and instruments and theories, its pale streak of light rested above us like a familiar gesture. In a world full of uncertainty, change, and wandering, the night sky offered one of the few constants that required nothing and explained nothing, yet always invited contemplation. There is something quietly profound in realizing that every person who has ever lived, no matter their landscape, language, or era, has shared this same faint river of stars. In deserts and forests, on the decks of ships, and from narrow valleys, people have paused to notice it. Some would have seen it often, others only during rare moonless nights when the sky finally cleared. But whenever it appeared the same. A gentle band of light, soft and continuous, stretching from horizon to horizon. Imagine someone thousands of years ago, standing barefoot on cool soil. They may not have had words for the sky's arrangement, no formal understanding of its structure, but they could still feel its presence. The Milky Way would have been a companion to their nights, just as it is to ours. A quiet reassurance that the world extended far beyond the boundaries of daily life. That pale band was proof that something larger existed, something serene and unreachable, and it asked nothing more than to be witnessed. As centuries passed and humanity spread across continents, the Milky Way continued to offer that soft invitation. Wherever people traveled, it traveled with them. It hovered above new settlements, over roads carved through hills, above lantern-lit gatherings and solitary journeys. It was a reminder that even as landscapes changed and civilizations rose and fell, the night sky remained an inheritance passed from one generation to the next, without needing to be claimed. One of the striking things about this inheritance is how democratic it is. The poorest shepherd and the richest ruler could gaze at the same sky with equal clarity. No border prevented its view, no barrier barred access. The Milky Way ignored all distinctions, shining with the same quiet glow for everyone who happened to look up. Perhaps that is why so many cultures found comfort in it. Not because they shared the same interpretations, but because they shared the same act of noticing. The act itself is simple: a momentary pause, a lift of the eyes, a breath slightly slowed. The Milky Way encourages this pause not through drama or intensity, but through its softness. It is not a spectacle designed to seize attention. It is a presence that gently invites reflection. Its glow is diffuse, its boundaries blurred, as though it prefers to be experienced rather than examined. Even today, when city lights dim its brilliance, people still seek out places where they can see it more clearly. Mountaintops, remote plains, quiet shorelines, drawn by a desire to reconnect with something older than memory. There is comfort in knowing that the same faint light that reaches our eyes tonight also touched the eyes of people who lived in ages we know only through ruins and guesses. They did not understand spiral arms or galactic centers or star formation, but they understood wonder. They felt the pull of curiosity, perhaps even humility, when confronted with a sky so spacious it offered no immediate explanation. The Milky Way's constancy, Its unchanging presence amid the shifting stories of human life creates a sense of continuity. It is a bridge between generations who never met, linking them not through spoken tradition, but through shared experience. No matter how different their lives were, they all knew the quiet glow above them. They knew the delicate way it spread across the night, too broad to be mistaken for a single object, too smooth to be dismissed as scattered stars. They knew the way it seemed to breathe with the turning of the earth, rising and setting like a slow celestial tide. Even now, when we understand its nature as a galaxy, this understanding does not replace the emotional experience. It simply adds another layer. The knowledge that the Milky Way is filled with billions of stars does not diminish its softness. If anything, it makes its presence more intimate. We can now appreciate that the gentle glow is not a smear of light, but the blended radiance of countless distant suns, each far too faint to see alone but together, creating something visible, familiar, and serene. Modern life often unfolds beneath bright lights, screens, and buildings that break the view of the sky into narrow fragments. But whenever people step outside that glow, at campsites, in dark valleys, or during unexpected power outages, the sight of the Milky Way can still evoke the same quiet response. A brief pause, a softened breath, a recognition, perhaps unspoken, that this view is ours, not because we earned it, but because it was always there, waiting to be noticed. In this way, the Milky Way becomes not merely an astronomical object, but a shared inheritance of stillness. It connects generations through a sense of presence rather than through story. It reminds us that across all the variations of human life, the migrations, the discoveries, the complexities, the simple act of standing beneath a star-filled sky and noticing its faint river of light is something we have always shared, and something that will continue long after we are gone. The galaxy does not ask us to understand it in order to appreciate it. It only asks that we look up now and then, the same way countless others have done, and let the soft brightness remind us that we belong to a universe much larger than ourselves. A universe that glows gently, patiently, and without prejudice for all who choose to see it. If the Milky Way had a favorite virtue, it would likely be patience. Not the kind of patience that taps a foot or sighs meaningfully, but the deep, ancient patience found in mountains or drifting continents, the kind that treats a billion years as casually as one might treat a quiet afternoon. The galaxy has survived for more than 13 billion years, not because it is unbreakable or impervious to change, but because it seldom hurries and never panics. When challenges arise, the Milky Way seems to handle them the same way an old tree handles strong winds, by standing there, giving the universe plenty of time to finish whatever it's doing. For instance, the galaxy has endured countless star deaths. Over the ages, stars have expanded, cooled, collapsed, flared, and sometimes exploded, each one an event that could, in principle, cause turmoil. But the galaxy never treats these episodes as crises. When a star reaches the end of its life, the Milky Way simply incorporates the change into its ongoing rhythm. Supernovae scatter heavy elements across space, elements that eventually become parts of new stars, new planets, and perhaps even living things. On the rare occasion when a star's demise sends shockwaves rippling outward, the galaxy does not react dramatically. The shockwaves pass through enormous volumes of space that dwarf their energy, stretching and fading like distant thunder heard in a vast meadow. Even the more energetic cosmic radiation, the kind that streaks across space like the galaxy's version of stray sparks, poses little risk to the Milky Way's coherence. These particles travel far, often for millions of years, but the galaxy's sheer size dilutes their presence. They become part of the background hum, mingling with the quiet glow of starlight and the soft wash of interstellar gas. If galaxies had a sense of mood, the Milky Way might treat such particles as gentle reminders that even in calm places, a little spark now and then keeps things interesting. And then there are the collisions. The galaxy has experienced more than a few of those, although collision is a misleadingly dramatic word. In human terms, a collision conjures images of fast impacts and sudden consequences. But when galaxies collide, the process unfolds over billions of years, with each participant behaving less like a battering ram and more like a very large, very slow dancer who occasionally brushes sleeves with a partner. Stars rarely touch. Space absorbs the movement with leisurely grace. The Milky Way has joined several such dances throughout its life, each time blending gently with the visitor until the newcomer becomes part of the family. One could say the galaxy's survival strategy is simple. If anything unusual happens, respond by continuing whatever you were already doing. Spiral arms keep rotating. Gravity keeps shaping the orbits of stars. New generations of stars emerge from drifting gas clouds. Old ones fade quietly out of sight. The galaxy is so vast that even events we might consider dramatic barely ripple through its structure. It is not that the Milky Way is indifferent. It is more that it has seen everything before and knows that change, however grand, is rarely a reason to behave differently. Even minor disturbances, like a cluster of stars wandering too close to a spiral arm, or a drifting cloud of gas choosing an inconvenient moment to collapse into new stars, are handled with gentle pragmatism. The galaxy makes room. It adjusts. It continues its slow, broad rotation without complaint. If the Milky Way were a person, it might offer a kindly nod and say, "Take your time, dear. We'll sort it out eventually." There is humor in this quiet resilience. The galaxy has endured scenarios that, if scaled down to human proportions, would be overwhelming. Entire clusters dissolving, gravitational tides stretching things out of shape, smaller galaxies arriving unannounced and proceeding to be gradually absorbed like acquaintances who came for dinner and never left. Through it all, the Milky Way keeps its composure. If galaxies could shrug politely, ours would do so often. This patience also expresses itself in the slow buildup of changes. Instead of resisting, the Milky Way adapts to each new development at the pace of geology multiplied by hundreds. Stars born from ancient collisions now shine comfortably in regions where their ancestors once drifted as strangers. Streams formed from absorbed companions wrap around the galaxy like scarves kept not for decoration, but for the quiet memory of how they came to be. Nothing is erased, but everything is softened by time. Even the galaxy's future challenges, such as its eventual blending with the Andromeda galaxy, will unfold with the same gentleness. Predictions suggest this future encounter will play out over several billion years, giving the Milky Way ample time to prepare, adjust, and likely offer its neighbor a patient welcome. If galaxies had mottos, the Milky Way's might be something like, "We'll take it as it comes," spoken with a kind smile and no sense of urgency whatsoever. Of course, patience does not imply immobility. Throughout its long existence, the Milky Way has continuously reshaped itself. Its spiral pattern has shifted with emerging star clusters. Its halo has expanded with the addition of scattered stars. Its central region has evolved as matter settled into new configurations. Yet none of these changes occurred in haste. They unfolded at a tempo so slow and deliberate that calling it change feels almost imprecise. It is more like gradual refinement or gentle settling. In the end, the galaxy survives not by resisting the forces that act upon it, but by embracing them with quiet persistence. It has learned, over billions of years, that the universe is full of movement, full of blends and dissolutions, full of beginnings and endings. Nothing stays the same, but nothing moves too quickly. And in this grand slowness lies the secret to its longevity. The Milky Way endures because it does not insist on stability. It accepts rearrangement with composure. It lets time do the heavy lifting. It gives everything space to unfold. And it continues, unhurried, adapting gently to whatever the cosmos brings, an ancient system that does not need strength to survive, only patience. Even now, as you settle into stillness, the Milky Way continues its slow drift through the dark. The galaxy moves with such quiet assurance that you feel none of it. No sway, no hum, no whisper of motion. Yet the entire world beneath you is being carried along by a structure so vast that words strain to describe it. And the beauty is that nothing is required of you. The galaxy moves whether you notice it or not. Your rest does nothing to slow it, and your wakefulness does nothing to speed it. It turns with the steadiness of something that has known its path for billions of years. If you listen closely, not with ears, but with attention, you might sense the calm this imparts. The idea that we are passengers on a journey too immense to measure, guided by forces too gentle to feel, can bring a kind of ease. It means that the universe does not depend on our vigilance. It carries on, giving us space to breathe, to drift, to close our eyes without fear of missing anything urgent. The Milky Way asks nothing of us, except perhaps the occasional moment of quiet appreciation. Above, the stars maintain their familiar positions in the sky, though in truth they are all moving, each with its own slow trajectory. Their changes unfold on timescales far beyond our perception, so the constellations remain comforting companions. Night after night, they appear in their expected places, like friends who always arrive early and never feel the need to announce themselves. This stability is a kind of gift, an unspoken assurance that the sky will not shift beneath you while you rest. Meanwhile, below those constellations, our solar system continues its long, graceful curve around the galaxy's center. Nothing about this journey is hurried. The sun travels through space with the demeanor of a traveler who has no schedule, no pressing appointments, and no need to check the time. It moves steadily forward, carrying Earth and its companions along with it, offering us an unhurried ride through regions of the galaxy we will never see directly but inhabit nonetheless. In the quiet hours of night, when the Earth has turned its darker face toward the cosmos, this sense of motion becomes almost companionable. You might imagine yourself floating gently on the surface of a slow-moving river, the water so calm that you feel suspended between motion and stillness. The galaxy's movement is like that, present but unobtrusive, a background current that shapes everything without drawing attention to itself. The world around you is full of cycles, day and night, seasons turning, tides rising and falling. These cycles echo the deeper, slower rhythms of the galaxy, though on a scale small enough for human senses to follow. A sunrise is a quiet reminder of Earth's rotation. A change of season hints at our orbit around the sun, but there is no daily reminder of the solar system's path around the Milky Way. No dawn announces our progress through the galaxy. No sunset signals our distance traveled. The journey is too large to register moment by moment. And so the galaxy's movement becomes something like a lullaby, steady, constant, unintrusive. Its pace is so slow compared to the heightened tempo of human life that it offers a contrast, a reminder that not everything is urgent. Not everything requires attention, and not everything demands understanding. Sometimes it is enough to know that you are part of something vast and gentle, even while you sleep. Imagine for a moment, drifting through space in a way that mirrors your own resting breath. Inhale, exhale. The galaxy continues its rotation with a rhythm that feels ancient and effortless. Its spiral arms sweep around the center in a motion that takes hundreds of millions of years to complete. Yet the motion is so smooth that even sensitive instruments must work hard to detect the slightest hint of the journey. You, in turn, feel nothing, and that is the quiet comfort of it. The night sky above you has been shared by countless people, but the motion beneath it is shared by every creature that has ever lived. Everything on Earth, mountains, oceans, trees, and the people who pass beneath them, has been carried through the galaxy without ever noticing. This shared passage creates an invisible thread of continuity, binding all life not just to the Earth, but to the larger structure that holds it. There is solace in the idea that you are carried, always, without any need for effort. Even as you lie still, perhaps with your eyes closed, the galaxy handles the movement. It turns with a steadiness that asks nothing from you. You are free to rest because the universe itself is unhurried. And as you drift toward sleep, the galaxy continues its patient arc. It will continue long after this night, and long after many nights. Its motion is not a cycle you must follow, nor a pattern you must remember. It is simply there, as dependable as the darkness that wraps the sky, as reassuring as the soft glow of stars that take their time to shine. In this gentle turning, there is no conclusion to reach. No final point awaits. The galaxy moves not towards something, but as something, an immense, slow dance that you accompany without trying. You rest within it, without needing to understand every detail. The Milky Way holds you in its wide, unhurried motion, carrying you softly through the dark, even as you sleep.